Welcome back. This is page 3 of section 5.4, and we're going to talk about the Pythagorean theorem again. So it says the square of the length of the hypotenuse, so hypotenuse is across from the right angle, of a right triangle is equal to the sum of the squares of the lengths of the legs. So let's write it down. The square of the length of the hypotenuse, so this is the hypotenuse, we're going to square that length, so c squared, is equal to, what is it equal to? The sum, meaning we're adding two things together, squares of the lengths of the legs. So these two are the legs, so we're going to square them, a squared, b squared, and we're going to add them together. Okay, so it's very important again that we have a right triangle for this. All right, next problem. The diagonals of a rhombus measure 6 meters and 8 meters. How long are each of the congruent sides? Okay, so to be able to do this problem, we're going to need a picture. So let's go ahead and draw a rhombus. Remember, a rhombus is a four-sided figure where each side is the same length. Okay, so we're supposed to find how long each one of these sides are. And we're told about the diagonals. So let's go ahead and draw the diagonals in there. Okay, and diagonals again. Okay, so there's our diagonals. Now remember, what is the relationship between the diagonals of a rhombus? Well, they meet in right angles. They're perpendicular to each other. Okay, so let's go ahead and do that. Then we know that this dimension here, it looks like the longer one, so let's call that 8. And this one here is 6. We also know that they bisect each other, the two diagonals. Because a rhombus is a parallelogram, then parallelograms have diagonals that bisect each other. So if this whole length is 8 here, and this chops it in half, then this piece would have to be 4. Okay, and this piece here would have to be what? Well, this whole thing is 6. It's chopped in half, so it must be 3. So here we have, let's take a look at what we've got here. We've got a right triangle, don't we? So there is our right triangle. And we have a side that's 4 and a side that's 3. So how would we find this side? We use the Pythagorean theorem. So in this triangle here, this is our triangle. It's 4 and 3. We're trying to find this side. So we are going to use the Pythagorean theorem. We have a squared plus b squared equals c squared. And the legs will plug in. And we don't know the hypotenuse, so we leave that as c squared. We square this one. 4 times 4 is 16. 3 squared is 9. We add those together, we get 25. And that's c squared. To solve, we take the square root, remembering to put in the plus and minus. The square root of 25 is 5, plus and minus, square root of c squared is c. So because we're talking about the length of a side, we know we're going to reject the negative. So c is equal to 5. So they're asking us what's the congruent, the length of each congruent side. Well, we now know this is 5, and since they're all the same, they're all 5. So we would say each side of the rhombus measures 5 units, whatever they are. And that answers the question. Okay, next up, we're talking about a Pythagorean triple. So it's a set of 3 whole numbers, a, b, and c, for which this relationship holds. A squared plus b squared plus c equals c squared. So of course we're going to have 3, 4, 5. That was our problem here. We can see our little triangle here, 3, 4, and 5. So that's a Pythagorean triple. Now any multiple of that is also a Pythagorean triple. So notice here we multiplied by 2 and we got 6, 8, 10. If we multiplied by 3, what will we get? We get 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. So that's another Pythagorean triple. If we multiplied by 4, we get 12, 16, and 20. So you can just keep going on and on forever with this. So what are some of the more common Pythagorean triples? There's 5, 12, 13, and then all the multiples of those. 8, 15, 17, all the multiples of those. So you can see there are many here. Okay? So the converse of the Pythagorean theorem. So remember, that's going backwards. So basically it's telling us if we have three sides of a triangle with C representing the longest side, and this relationship holds true, that C squared equals A squared plus B squared, then what can we conclude? We can conclude it's a right triangle, and the right angle is opposite that longest side C. All right? So then we can conclude that this is a right triangle. So we're saying if C squared equals A squared plus B squared, then triangle is a right triangle. Okay, so that's what it says. Okay, that finishes page 3. Go on to page 4.